Okay, great. All right, welcome everyone to the VICC General Call. It's great to see so many familiar faces on the call today. We have guests from the NCI talking about the NCI Thesaurus Explorer and the EVS services. My understanding is that Brian Carlson will be presenting on behalf of himself, Lori, and Lyuba on the work they've been doing in the EVS Explorer. Feel free to go ahead and take it away, Brian.
Okay, I'll share my screen here. Yeah, so EVS Explorer is a terminology browser that currently is set up to provide access through this user interface and a backend API to NCI Thesaurus content for the community of cancer care and cancer research. So here we are on the landing page. I'm just going to go through a kind of demo of the current features and then talk about what's upcoming, because there is a new release of this that's going to be available pretty soon. So here we have a basic landing page for NCI Thesaurus. You can tell which version of the terminology is loaded up here. This is updated monthly. So the end of month official releases of NCI get loaded in and become available on the same day. So this will evolve into a browser that contains content for other terminologies as well, including NCI Metathesaurus and individual terminologies like Medra or Radlex and other things that are of importance to the cancer research community. I think the first thing to do here is just perform a search. So I'm going to kind of assume that people are familiar with NCI Thesaurus content, but it has a lot of coverage of, you know, disease areas related to cancer, gene information, other kinds of stuff. So I'm mostly going to demo this rather than talk about the terminology itself, but we can do that if people are interested. So here we have a series of search results. You know, here you can see pancreatic adenocarcinoma is the thing we're looking for. Basic set of search results. You can see highlights of the reasons why this was returned as a search result, the code, and some other basic information about this thing. From the search results, we can click on a concept here and go to a detail view of this thing. And here, this is really kind of just for historical reasons and abridged for other users, but there's kind of 3 tabs along the top here. And view all just combines the perspectives of the other 2. So we start at the top here with just some basic information about the concept, its name, display name, its code, then definite table for the definitions, a table for the various synonyms and abbreviations, including content from a variety of the different subsources that are available in NCI Thesaurus. All these tables are kind of collapsible and sortable on the various columns. General property information, where possible, these link out to pages for the actual resources underlying these kinds of identifiers. Mapping information, here we have some relationships, so parent concepts of this concept, child concepts of this concept, and these are links so you can load and open these pages and kind of navigate through the chain of concepts. Role relationships, so these are the kind of ontological defining relationships of the NCI concepts. Associations, so here we've got this concept as a member of a variety of different subsets, which we'll look at in a second. And then we have incoming, or sort of the reverse role and association relationships. Another perspective very similar to this, you can look at this thing in the NCI Thesaurus hierarchy. So if we come here, you'll see that it loads basically the same view on the left, but on the right is the concept hierarchy for NCI opened to this very concept. And because of the way NCI Thesaurus works, it's possible for a concept to have multiple different positions in this tree, so they're kind of all made available here. And then from this view, you can sort of browse your way around also, and clicking on things on the left here will load the corresponding concepts for you on the right, and then also look up again the various tree positions of the new concept that you're looking at. And this lets you kind of browse around the entire tree. Okay, Okay, let's go back to the search for a second. There's a number of search modes here. You'll see is contains, exact, starts with. Like to look at fuzzy because we can put in something here that's got a bit of typo in it, so can be a little tolerant for those things. We can do exact can't matches, and then only get back concepts that have synonyms or preferred names that exactly match the text that we're looking for. Or we could, you know, do the starts with kind of search. So here, only things that have entries that start with the word bone will show up. And then, you know, in this table of results here too, I wanted to point out that you can kind of tune what we see. So if there's only certain things you're interested in looking at in the search results, you can change the display of this table so that only the fields that you're interested in looking at are here. And of course, there's paging controls to look through the variety of all of the other fields. The other thing we can do is restrict searches to content in which there are subsource definite, you know, subsource content. So here, let's see, yoink. Let's try this one. You can select a number of different things. So here, with these restrictions, we're saying find matches to this text string only where these subsources have matching content. So if we come into this one, you'll see that we selected CTRP, and in fact, there's matching CTRP content for bone cancer in this concept. So it's a way of kind of tuning the search results additionally to include a specification that one of these sources is involved. We can reset the search back to here. A couple other features to show. There's this subsets link on the header here. And if we go to this, this is a table of all of the subset information that's defined in NCI thesaurus. These are a variety of curated sets of content that are actually in NCI thesaurus itself. And we can kind of make our way down here and look at one of these things. So actually really any of these is fine. So this is kind of the table of all the subsets hierarchically organized. So, you know, there's some structure to how you get to each of these things. And then if you click on one of these individual subsets, you can see the contents in a searchable kind of view. So I could search here and restrict to just the things that have matches kind of like on that main screen. And we've got links to the actual download site where these files are available to be downloaded. All right, and then we took a look at the hierarchy thing. We've got inline metadata documentation in this application as well. So all of the model itself returns a concept object from the API that has all the different features of it. And these are kind of definitions of all the types of things that exist. If we go to all metadata here, you can kind of see everything. So these are the codes and names of all the associations that are used for the data set that's loaded, and then definitions of those things. And then this metadata includes kind of like all the types across everything. So property, codes and names, the roles, qualifiers, roles, we got definition types, synonym sources and types, and so on. So there's a complete kind of metadata closure across all of the content that's in here. And then there's some interactive help within the application as well that kind of tells, you know, guides you on how to use it, where to click, what the different features do, and generally how to use the application. And, you know, this is a feature that will continue to evolve and improve over time and account for new features that come along the way. This application itself is backed by an API that provides access to all of the content. So here's the Swagger page for the API. And we've got sort of, this is really just for version information. We've got endpoints that let you specify, you know, that you want to load an NCIT concept. So for example, we can put this example provided in here. And then you can see the kind of raw data that's used to drive the API. So here's what a concept object looks like. and you can specify kind of how much information you want to have this thing come back with. We looked at the metadata, this documentation metadata thing here. So that's driven by this metadata API that provides essentially access to the lists of all of the types of metadata that are used by those concept objects. And then you can load more detailed information about individual ones as well. So try to provide a whole perspective on content as well as on metadata. This content endpoints also support the hierarchy. So there's ways to look up descendant lists. There's ways to look up a sort of visualization ready hierarchy of nodes from the top. And then of course there's a search endpoint. So you can specify what you want to search for. There's some features in the API here that go beyond what is currently available as functionality in the browser. So in this situation, you can restrict by a variety of other things, including searches by property values. And you can be even more specific about the types of synonyms that you want to match to and things like that. And some of those things will become features in the UI eventually anyway. And then up here, there's another link for any technical people on the call. There's a client SDK project that provides kind of out of the box examples in a variety of environments and programming languages for directly interacting with the API. So, you know, you can just pull this project down and begin running and making API calls. The next version of this will include access to NCI Metathesaurus as well as NCI Thesaurus. And otherwise, the sort of basic features of searching and finding content and looking at detailed views of concepts will apply in this situation to both NCI Thesaurus and NCI Metathesaurus. And from there, we'll kind of develop this to increase the feature set, but also increase the specific loads of content that are available through this tool. Lori and Lyuba, I don't know if there's specific other content that you think would be worth showing. That's a kind of basic review of the features.
Thanks, Brian. I think maybe actually if we turn it over to the group, if they, you know, want to see something specifically or have some comment.
Yeah, thank you, Brian. And please, you know, whoever has any questions or suggestions, we are happy to listen to you.
I'll say this doesn't require an account. Also, you can just come here and start using it. It's available. It should always be up.
Cool. This is it's really phenomenal. The you know, the NCID source, it's, you know, and these associated products, they're all, you know, they're quite large and extensive resources with a lot of relationships. To be able to search and browse them so rapidly is very impressive. I was wondering if you wanted to comment a bit on the underlying like architecture that enables this. And, you know, the ability, well, let's start with that. Let's start with the architecture. I am curious about, you know, how you guys basically enabled the ability to find all these concepts so quickly.
Yeah, so good question. The architecture is pretty straightforward. I mean, there's a REST API front end that requests come through, but the searching is supported using Elasticsearch, which is a technology for supporting textual searching of documents. You know, I think it was an outgrowth of Apache Lucene, which was a project from some years ago to really make high performance text searching available in a variety of environments. And Elasticsearch is a kind of hosted server version of that environment. So you put things into it, it indexes them in a variety of different ways as specified by you. And then it just through its own API supports the ability to perform searches against it. So we load the data from NCI Thesaurus, which is released as an OWL file, into a triple store environment. And then we run a process that basically pulls each concept out of that triple store environment and loads the index into Elasticsearch. And then the backend API pulls data. I mean, it really pulls data from Elasticsearch because this is not an editing environment. The data is static. So for each release, we can just have a copy that's fully indexed and available. And we actually put the data in there too. So all the concept retrievals come from that environment as well. So it is quite snappy. I think we were able to, in a straightforward way, download all 150,000 concepts from NCI Thesaurus in a matter of a few minutes. So that was an important consideration.
Very cool. In terms of resource usage, this has a very nice user interface associated with it. You've also built out this API. Are there limits in terms of how often the service may be leveraged by clients in terms of either queries per second or overall queries or anything like that that people should be aware of?
Not specifically. I think right now what we're doing is kind of making greater awareness of this application. We are tracking, its usage, both from the UI perspective and gathering metrics on the back end. Right now, it's not deployed in a way that's sort of like clustered or excessively or extremely fault tolerant or anything like that, because there's not a need at this moment in time to do that. We're not rate limiting anybody either. And we do have users that periodically, let's say once a month, do make volumes of calls against it. So, we haven't had a problem with that yet, but it's something we'll have to keep in mind going forward. I think in general, the idea is that this should be a high performance, always available application that people should be able to use as they see fit. And, if someone were really expecting to do tens of thousands of queries per second, it would probably not be recommended to use a public instance for doing that. But this is all, I should mention too, everything here is in GitHub as well. So it would be possible if somebody really wanted to run all of this themselves to do such a thing. But I don't know if Lyuba or Lori, you have ideas about what the sort of SLA kind of approach to all of this is in the long run, or whether your expectation is for people to build applications on top of the API directly, or what volumes of traffic you intend to support in the long run.
I have two small additions to your perfect explanation, Brian. The first one about the architecture of and why the performance is so good. As a non-technical person, as a science person, I can say that the base on which this architecture is based and so effective is the architecture of brains of Brian's team and his personal brain architecture. That's why it's so effective. The second, we anticipate that there will be some additional features on the top of the current API because we have some users using very big amounts of terminology. So potentially, at least I foresee some project-specific URLs for API, kind of tuned to particular purposes, so the query will not be that huge, not the entire NCI Thesaurus content will be under the search, and potentially, given the current interest to data integration and data commons, there will be huge queries. That's what we anticipate.
Very nice. I was curious about updates. So you mentioned, as you version the data set, that there are, static version releases. I see here version 21.11e. Presumably that version corresponds to the data and not the application.
That's correct.
Okay, and 2111 meaning the 11th month of 2021.
E meaning the 5th weekly release, or the release of the 5th week. Yeah.
Oh, so this is released on a weekly basis.
Well, there's sort of interim versions that are available on a weekly basis, but the what's available through EVS Explorer are the monthly versions, because I think only the monthly versions are sort of official releases, if I'm not mistaken.
Correct, and the internal NCI programs like CTRP, Cancer Treatment Evaluation Program. They have weekly releases because they support clinical trial search engine. So we need to supply weekly updates for protocol abstraction and to support clinical trial search for public and physicians.
That's excellent. Thank you. Any other questions for Lyuba, Lori, and Brian?
This is Dmitry. I'm just curious. When I looked in the Explorer, for example, there are some entries for the particular variants. And some of them, for example, classical BRAF V600E would also have entries with complete HGVS string. So I'm curious how this code are used now and who is using them.
So that's a content question that I'm not sure I'm prepared to answer.
Sure, I think Lyuba and I can probably address that. Can you ask the question one more time, please?
Sure. So for example, perhaps you can just go to this code so we can all see it. So code is C like color 98344.
So a particular variant.
Exactly. So what I'm curious is who is currently using this type of codes and for what purpose? I'm just curious.
In many cases, you can figure out who is using this particular concept, and in this case, the variant. You see two contributing sources, CPTech and CTRP. So it looks like they're using this as CTRP is using this concept to code a biomarker in a particular protocol and clinical trial search. This is cancer treatment reporting program, and CPTech is a consortium for cancer pathological something. It's the collection of samples from cancer tissues for a number of neoplasms, which is now merged with Data Commons node for not genomics, but for proteomics research. So this concept is used by two of these sources, but sometimes we have requests to have a concept for variant or for a biomarker, but the requester is not listed as an official contributing source. So it's used by some source, but there is no indication in NCIT. So it's kind of selective information here.
Okay, so theoretically one can imagine, for example, something like clinical trials, so NCI Match could potentially use it.
Yes, yes.
Okay, and another partially related question. So this is one of potential nucleotide, not potential, it's one of the nucleotide changes which will cause BRAF V600E change. Now there are a few other nucleotide changes which theoretically could cause the same change. And there is separate entry for the protein change. Now, I'm just curious, is there any concept here which would take the particular protein variant, something like V600E or whatever is applicable, and then let's say this particular protein change could be caused by following nucleotide changes. So essentially listing all possible nucleotide changes which could cause particular protein change. which are identical.
I'm not sure I understand the question.
Right. So if you go to, thank you, Brian, for opening. So this is where the entry.
Yeah. I think that's your answer exactly, though, is that in here, the role relationship describes the connection between the sequence change and the protein change.
Right. So what I'm curious is, I don't remember from the top of my head. Sorry, is it possible for this, but I don't remember free nucleotide contacts here, so I don't remember for sure. What I'm wondering is if this particular protein change, okay, so let me see, what may be my answer, okay.
I think this might be your answer.
Okay, so here you have essentially two nucleotide changes which would cause exactly the same protein change. I see. And is it always complete, meaning if you have a protein change which could be caused by multiple nucleotide changes, do you always going to have all of them listed here?
We try to keep it updated.
Yeah.
Of course, you know, there could be some missing pieces, but we try to be, you know, on the top of this, you know, events of discoveries when it's available in the literature or coming from protocols. And we have, you know, we have a submission form for NCIT. And if you have information which is currently not present in NCIT content, and you think it's already verified and is available, and we are missing it, we are encouraging you to supply this information through our web-based form.
Okay, so I'm curious. So in some instances, if you're talking about just simple single nucleotide change, it's possible theoretically to see what this particular protein change could be caused by, let's say, 2 or 3 nucleotide changes. So I'm just curious, in cases like that, do you just check and see what is theoretically possible?
It's theoretically possible if this information available and it's represented. You know, we are not establishing anything. We collect the verified information from the literature.
Yeah,
and from researchers.
This is not intended to be a definitive resource for this kind of information specifically.
Right. No, I'm just trying to understand how people in different resources are trying to represent this. So it's just interesting. Thank you.
Yeah.
Yeah, I think you're just asking sort of modeling questions, and that's what we do on the content side. And as Brian and Lyuba just said, it's all published information, and we try to update as quick, you know, and stay on top of it as much as possible. And we also do like feedback from the community, as mentioned with the, you know, things are always changing, you know, whether it's, you know, neoplasms, we update with every time WHO updates another blue book, we bring our NCI thesaurus neoplasms up to date based on that. So we, you know, and we try to cover this across the board, whether it's in the drug space, genes, neoplasms, diseases, you know, so.
And I can add to Laura's note that in many domains like neoplasm, we are ahead of other established standards. For example, for neoplasms, we provide the molecular characteristics of neoplasms which are not present in clinical classifications provided by WHO because they are pretty kind of conservative for obvious reasons. We provide this additional characterization, and it's always evolving. So when the substantial information is available to provide the particular variant of neoplasm or particular type of biomarker which is accepted by the some part of the research community, we enter this information, but we always, welcome feedback from people because different groups of scientists have different views of and different methodologies, so it's evolving.
And I'm just curious, so you mentioned the term neoplasm is of course a classical term that covers the malignant condition and also covers benign neoplasms. And in the past, unfortunately, there was a number of people who didn't really understand it. So I'm curious from your work with different groups, is the understanding of this is improving or still sort of there is a confusion in community, at least in some places?
So if I understood correctly, we have, so the neoplastic space has both malignant neoplasms and non-neoplastic diseases, and you can see that in the hierarchies. And then also by definition, and also the neoplastic space is probably the most complicated modeling that we have in the NCIT. I'm not sure if I answered your question.
Partially. What I'm just trying to understand is, because as you mentioned, it's complicated and it's not necessarily the term which many people in community used, and because of this, at least in the past, the term sometimes was not completely correctly used. So for example, some people assume neoplasms are by definition benign, which of course not the case. So I'm just curious to see, based on your communication and work with different groups, is understanding of this concept is improving, or still there are some people who don't get it?
It's always complicated, this classification. We present the kind of classic classification, as Lori mentioned, WHO updated information with which we are now in a full synchrony. We have updated our content to the latest standards, but over this, we have additional information which sometimes could be interpreted by different groups differently, and the most current kind of approach is not to classify the neoplasms by only topography and morphology, but mostly classify by the molecular characteristics, regardless practically of topography, and even the biggest trial which now attracts the most interest is the match trial, which stratifies the population of patients not by the topography of neoplasm, but the particular mutations type, particular biomarkers, and this is the current approach. So the classification is a very fluid entity. So we try to first reflect the current clinical, established approaches, but at the same time to follow some modern concepts which could change over time. As you mentioned, the new discoveries come, the new mutations, new variants come, so it's changing, but still it should be in the framework of current clinical data standards, so data could be, integrated meaningfully, and the results of analysis provide some meaningful results. I hope I understood your question correctly.
Yeah, no, thank you for that. And I'm just curious, while we're looking at this page with BRAF mutation, maybe I missed it. So I'm just curious, is there a link, for example, if there is the entry, corresponding entry in the ClinVar or ClinGen allele registry, is there a link to this entry from this?
I'm not sure that I'm understanding what you said, that what link are you looking for?
Like ClinVar, is there a link to ClinVar?
I don't think so.
Okay.
I was
Okay,
gonna
thanks.
check, but
Yeah, and and I'm also not sure that we've fully answered your question about the neoplasms, or maybe even understood the question correctly. But I would say that the way that they are modeled, we keep it very strict. So, if I heard you correctly, you were sort of asking, do our users understand what it means to be a neoplasm?
Yes, yes,
Yeah.
and do we use it correctly?
Yeah, so I don't know that we've seen a lot of confusion from our users, but we certainly design and model the NCI thesaurus in a certain way. So I don't think that it's questionable as to what is a neoplasm versus what is not. We have a pathologist who actually defines all of this. And so he keeps very, strict things. It's not, cysts and things are not going to be considered a neoplasm, without the proper histology. So does that help a little bit?
Yeah, thank you.
And also we provide, to the extent we are able to, we provide some links in modeling and some relationships which clarify the meaning of the concept, not by the definition only, but by the ontological approach through the relationships. So the modeling provides you the information about the concept through this network to other concepts within NCIT, and through the additional links to other terminologies. For example, if we are talking about genes, we provide some links to Hugo gene nomenclature standard for neoplasm morphology, to ICD-10 codes. So it's kind of complicated but pretty comprehensive information, not only about diseases, but about other domains also. Like for drugs, we provide the information about the target, and from target you can travel through the terminology relationships to molecular characteristic to the particular protein, to the particular gene, so you can create the complicated, comprehensive query to retrieve this information.
Thank you.
If you wanted to, you definitely have the information there to link to ClinVar.
yeah.
That would be useful. You can just copy and paste some of the HGNC things and they will go right in.
Right, yeah, I think if it's possible to add the link to ClinVar, I think it would be really useful, because it sort of creates back and forward linking plan.
Mm-hmm.
It's much easier for people than to say, yeah, that things are indeed identical.
Okay, it's a good idea.
It is, yeah, I
Thank
like
you.
that suggestion.
All right, are there any other questions for the EVS team? All right, hearing none. Thank you all for your time today and for the presentation and the walkthrough and answering all of our questions. It's a pretty amazing resource you guys have stood up, and we appreciate you taking the time to share it with us today.
Well, thank you so much, and thank you for your interest. And if you have any, ideas how we can improve and be useful for the community, please communicate it to us. Thank you.
Yep, thank you.
Thank you. Have a good day, everybody.
Thanks all. Bye.
Bye.
Bye.